How does the pancreas precisely releases insulin? Imagine your body as a finely tuned machine that needs just the right amount of fuel to run smoothly. After you eat, your blood sugar rises, and your pancreas springs into action to help keep everything balanced. The key players here are tiny clusters of cells called the islets of Langerhans, especially the beta cells. These beta cells are like the body's insulin factories, and they respond to the increase in blood glucose levels by releasing insulin in a very controlled way. When you eat, glucose from your food enters your bloodstream. This glucose then travels to the pancreas, where it enters the beta cells through special transport proteins called glucose transporter proteins. The most important one for this process is called GLUT2. Inside the beta cells, glucose is broken down through a process called glycolysis, and then it goes through mitochondrial oxidation, producing energy in the form of adenosine triphosphate, or ATP. As ATP levels rise inside the beta cells, they cause a change in the activity of certain ion channels on the cell membrane. Normally, potassium ions flow out of the cell through ATP-sensitive potassium channels, helping keep the cell at a resting state. But when ATP levels increase, these channels close, stopping potassium from leaving the cell. This causes the cell membrane to depolarize or become less negative inside. This depolarization then opens voltage-gated calcium channels, allowing calcium ions to flood into the beta cells. The influx of calcium acts as a signal that triggers the releases of insulin stored in tiny granules inside the cells. These granules fuse with the cell membrane and releases insulin directly into the bloodstream in a process called exocytosis. This releases happens in two phases. An immediate first phase from insulin granules already docked at the membrane, and a second, sustained phase where additional granules are recruited and released over time. Beta cells are also connected to each other through tiny channels called gap junctions, which allow them to work together in a synchronized manner. This coordination results in pulsatile or rhythmic insulin releases, which is more effective at controlling blood sugar levels. Besides glucose, other nutrients like fatty acids and amino acids, as well as hormones such as glucagon-like peptide 1, can influence insulin secretion, but glucose remains the main trigger. Maintaining the health of these beta cells is crucial for proper insulin releases. Damage or dysfunction in these cells can lead to diabetes, which is a known risk factor for pancreatic diseases, including pancreatic cancer. When pancreatic cancer develops, it can disrupt the normal structure and function of the pancreas, further impairing insulin production and regulation. Understanding this precise process highlights how important it is to support pancreatic health through healthy lifestyle choices and early detection of pancreatic issues. If you have concerns about your blood sugar or pancreatic health, it's always best to consult with a healthcare professional for personalized advice.